गुड मॉर्निंग बच्चों। आज हम ली-चैटलियर्स प्रिंसिपल के बारे में डिस्कस करेंगे। व्हाट डज दिस प्रिंसिपल सेज दैट इफ ए सिस्टम इन इक्विलिब्रियम इज सब्जेक्टेड टू ए चेंज इन कंसंट्रेशन, टेम्परेचर और प्रेशर, देन द इक्विलिब्रियम विल शिफ्ट इन दैट डायरेक्शन which will counteract the change or will minimize the change. Okay, suppose this is the equilibrium reaction given to us, which is the formation of ammonia by Haber's process, where nitrogen and hydrogen are reacted to form ammonia in the presence of iron catalyst. Okay, सबसे पहले सपोज हम कंसंट्रेशन का इफेक्ट देखते हैं. Okay, so if I increase the concentration of say nitrogen gas or hydrogen gas, because both are the reactants, so if I increase their concentration of reactants, then as per the principle this equilibrium will shift in the direction that will reduce the concentration. Okay, that means it will move in the forward direction, because in the forward direction the concentration of reactants is getting decreased. Okay, so if I increase the concentration of reactants, then equilibrium will shift in the forward direction as per the Le-Chatelier'S principle. Now we will see the effect of temperature and pressure, which are more important. So first let us see the effect of temperature. Okay, we will take the same reaction, that is N2 plus 3H2 gives 2NH3 gas. Oh, this is the equilibrium reaction. Okay, now we know that this is an exothermic reaction. That means delta H is negative for this reaction. Okay, so if I increase the temperature, then as per Le-Chatelier'S principle, the equilibrium will shift in the direction that will reduce the temperature. Okay, that means it will move in the reverse direction, because forward reaction is exothermic and reverse reaction will be endothermic. So as I increase the temperature, equilibrium will shift in the direction that will absorb the heat, means in the reverse direction, because reverse direction will be endothermic where heat will be absorbed. Okay, and if I reduce the temperature, then it will move in the forward direction, because in the forward direction this is exothermic, that means heat is released. So if I reduce the temperature and the equilibrium moves in the forward direction, if it moves in the forward direction, then heat will be released, and when heat is released, then temperature will increase, so it will counteract the change as per the Le-Chatelier'S principle. इसी को हम गिब्स फ्री एनर्जी के बेस पे भी वेरीफाई कर सकते हैं. As per the Gibbs free energy change, we say that delta G is given as delta H minus T delta S. अब इस रिएक्शन के लिए we know that delta H is negative, because this is exothermic reaction. Okay, now suppose delta S is also negative. Let us assume that delta S is negative. Then this minus T delta S term, that will be positive. Okay, so this term will be positive and this is negative. So for delta G to be negative, we should have temperature that should be less, because it should be less than delta H by delta S. Then only my positive term should be less. Okay, because delta H is negative, but this term will be positive, as delta S is negative, so this term is positive. So positive term should be less than negative term, then only delta G will be negative, and that will happen when temperature is lower. So for exothermic reactions, it is proved that temperature should be lower, then only reaction equilibrium will move in the forward direction. Okay, we take the effect of pressure. Effect of pressure. We will take the same reaction, that is N2 plus 3H2 gives 2NH3 gas. And effect of pressure is more pronounced in gaseous reactions only. Okay, because where the number of moles are changing, there only the pressure will affect. Suppose I write a reaction, water gas shift reactions, that is CO gas plus H2O gas gives CO2 gas plus H2O gas. This is called water gas shift reaction. Okay. Now we see that 2 moles are on the reactant side, and 2 moles are on the product side. So there is no change in the number of moles. So this reaction will be unaffected by the pressure. So whatever be the pressure, whether we increase the pressure or we decrease the pressure, this reaction will not get affected. The equilibrium of this reaction will not get affected because there is no change in the number of moles. But in this reaction, we see that 4 moles of reactants are getting converted to 2 moles of product. Okay, that means number of moles is getting reduced. Now we know that if we increase the pressure, the equilibrium will shift in the direction that will try to minimize the pressure. Okay, so as per the, we can understand by PV equal to nRT. Okay, we know that at a given temperature, T and volume of reaction vessel V is fixed. Okay, for a given volume of reaction vessel, V is also fixed. So we can say that P is proportional to N at a given T and given volume of reaction vessel. Now we see that the number of moles is getting reduced in the forward direction. That means pressure will also get reduced in the forward direction. So if I increase the pressure, then equilibrium will move in the forward direction. Equilibrium will move in forward direction if I increase the pressure, because as per Le-Chatelier'S principle, equilibrium will shift in the direction that will counteract the change or that will minimize the change. So I am increasing the pressure, means equilibrium will shift in the direction that will reduce the pressure, and in the forward direction, as the number of moles is getting reduced, so pressure will also get reduced. So we can say that high pressure will be favored for this reaction where the number of moles is getting reduced. Okay, with this I complete this session, and one more thing I will tell, that effect of catalyst on equilibrium. Catalyst will not affect the equilibrium, it will not shift the equilibrium, because it will increase the rate of both forward direction and reverse reaction. So it will not shift the equilibrium, it will change the both rates of forward as well as reverse reaction equally. Okay, so effect of catalyst is not there on the equilibrium. It will only bring the equilibrium quickly. If we use the catalyst, then equilibrium will be achieved in a less time. That is only the effect of catalyst, but it will not shift the equilibrium in either direction, because it will affect the both the it will increase the rates of both forward as well as reverse reaction. With this I conclude this session and wish you all the best. Thank you.